So, hello everybody. It's really, truly exciting to be here. 40 years to SolidCAM. Really exciting. And to a company that had started before 40 years with creating a toolpath for CNC machine and become an international company, big company that leading the CAM market. Well, this is a great honor for me and I think for all of us. So my presentation today, the complete solution for every workshop, will give some overview on the high-end solution of SolidCAM and also many other tools that's so important to any user in the daily work. Okay, I will start with this slide. As you can see here, there is a beautiful and complex part, which I took photos of them in the last AMB exhibition in Stuttgart before 10 days. What is the common of them is that similar parts have been machined and programmed day by day by SolidCAM in many other workshops and factories around the world. So I think it's a big source of pride for all of us. So SolidCAM today, I call it the complete solution. We actually give a complete solution to every factory, every workshop. We start with the CAD, with the design. We integrate it in SolidWorks mainly, and also with Inventor, and with SolidEdge, and also Tencon, how it's called, Emil? Thank you, Gan, okay. And we have our own product, SolidCAM, which gives today full solution to every CNC machine, to milling, turning, mill turn, now wire cut also, Swiss type. We have the Simco editor today, include the machine simulation, and now also VeriCut. Last lecture before was also VeriCut. This gives confidence to the programmer before he going to the machine. It's very, very important. It's complete our package. And we have also a great answer today to the operators in the factory. So the operators have SolidCAM operator package, so he can understand, he can have a clear pictures of the programming before he going to the machine, before he will push the green button in the machine. So all this circle is a complete solution for every workshop, and after 40 years, this is a great achievement of SolidCAM. So I will start with our high-end solution to mill turn, complete solution for advanced mill turn machine. So you know that more and more workshops today equipped with mill turn machine. And what is the reason? The reason is that they want to finish the entire part, include all the milling and turning operation in one setup, in one machine. This is the reason. And SolidCAM today give them all the powerful tool, all the necessary tool they need to make it. And we support all major brands in the market. We support Okuma Multus, Mazak Integrex, DMG, Nakamura Tom, Bumatec, Williman, and much more. Number of installation of SolidCAM of mill turn is 9,200 seats worldwide. It's great achievement. I will be going to show you one example for one of our veteran customers in Israel that he want to program and machine this part. And what is special about this part, what is the challenges in this part, is first is small size. There is this proportion here between the small diameter and the length of the bar. So we need to take care about vibration, to avoid vibration. We need to keep accuracy, it's very accurate part. And also mass production, 1,200 pieces. It means that every second, every minute is a pure money to the company. So it's very important. So let's see how this programmer combine a powerful functionality of SolidCAM with the wisdom technology, CNC technology of the factory. So as we can see here, there is a very small diameter here of smaller than 3 millimeter, along 32 millimeter the bar. It will program to machine, to DMG machine, DMG Mori, with back spindle, main spindle, upper turret, B-axis, and lower turret. And we will jump directly to the machine simulation. By our MCO, first, we can see how we pull out the material to the right size, and immediately we continue very simple by the lower turret. We continue to start to make the turning operation. So we can see a face turning, and after it, external turning. And after we finish with the turning operation, we change tool, and by MCO, we move the lower turret to safety place. And you can see that the programmer here decided to finish all the milling, also milling operation, in a very short portion of the bar. And this is very wise, because he avoid vibration by this. He finished with all the turnings, all the milling operation in very short bar, and now you can see how we continue. Continue to the second part of the bar, and we can see now by our fantastic solid host simulation that we make the operation of the turning, the continuous turning operation. And now you can see eye machining. Eye machining not just for milling, and also to mill turn, very important. And what is the reason that we use eye machining in mill turn? It's not just to reduce time, this is obvious, but also to keep a suitable process. It's very important in part like this. Very small part, we want to avoid vibration, so eye machining is perfect for this. We know there is a constant force on the tool also, and as you can see, it's a eye machining from we call it from the face, and after it, this programming continue to make eye machining also from the top of the bar. You will see it here. We can see with eye machining that the tool, all the time, the tool is free. It's work very easy in the material. And every operation for the user is very, very simple to define. Few seconds, you define, you may calculate, and you get and with eye machining, of course, we have also the result. So as you can see here, we rotate the part 180 degrees, continue the eye machining for the second size, and now in eye machining, he have also the rest material. So he will change the tool to smaller tool and finish with the eye machining in the same technology. So this programmer continue with all the finishing operation with multiple position. To define position in SolidCAM is so easy. Few seconds you define another position, and then you need to select the operation. So this is what we call easy to use, user-friendly software. You can see now another operation of eye machining from the side of the bar. And after we finish with this, we will complete now all the finishing operation now. As you can see, it's very fast. You can see chamfering, profile, drilling. As you can see here, now we work with HSS, for example. HSS is something basic today in our system. When I sell 2.5D, HSS is inside. Is one of the packages because it's so easy to define and very powerful to machine surfaces. We can see another operation like chamfering here. And now, what is the challenge now? The challenge now is to disconnect the part. To disconnect the part with the right dimension, of course. So we start with some grooving, turning with the groove tool. And now, how we do it? So by our MCO, we will call the back spindle. We will hold the part now from both sides. So we will have a very settable clamping. And now, with the finish, with the profile, with the tool, we disconnect the part and also get the right size. So this is not complicated, but it's very smart way to program a part in mill turn. OK, let's switch to milling. Now, I want to show you also one of the parts that I use to demonstrate all the time, and also my team demonstrate, because we have a lot of operation that we can show. But I want to show here complementary tools that we have in SolidCAM that not all the time get the attention they deserve, okay? And I will show it here in this slide and after it in the part. So you can see at the top, we have a T-slot tools, and so we have a T-slot operation in SolidCAM. In the side, we have the angular head. The angular head is very useful today and very demands by the customers. So as you can see on the right side, we have the angular head, and we support also here. And we have the probe. We support, SolidCAM support today, all the probes of Renishaw, of Bloom, of Hexagon. So we have a solid probe operation. And in the right side, we support thread milling. We have a thread tool. We have a thread milling operation, which support tools like of companies like Vargus or Carmex. We have a specific operation for each of these tools. So let's see. Actually, it looks like a simple part. We call it a prismatic part. But we can show in this part a lot of operations in SolidCAM. So let's see. We have a thread holes here. We have many pockets and islands. So first we define a very nice fixture for it with a vise that clamps the part. The machine, in this case, will be Haas UMC 750 with a tilt around y-axis. And so let's start. So the first thing we do when we're going to program, we use the solid probe in SolidCAM. Solid probe, very easy to define. We want to check the work coordinate system and to transmit them to the controller. So we have a lot of options inside solid probe. If we select the boss option, then we need to define automatically the system get us 4 points to touch. And as you can see now, we touch the material, transmit the z-axis, and after it, touch 4 points and send the center of the material directly to the controller. Continue to toolbox. Toolbox come to solve a specific, to give a specific solution to a specific case, but it's very, very useful case. In this case, for example, we want to machine the corner here. So instead of taking a profile or something that will waste movement, we take the toolbox, we take an option that's called a simple corner. Very strong. We just need to define the geometry, define the tool, any tool like profile, step down, step over, save and calculate, and when we look, we will see a very efficient tool pass with no air cutting, exactly what we want. And let's see the simulation, the Solid Verify of this corner. Perfect solution, and there have many other solutions inside. Now, in this part, we have a slot. We have an undercut slot. So we have a specific solution for it. We have a T-slot. T-slot, when we select the T-slot operation, automatically in the toolkit, we get two kinds of tools. We have a slot mill and a dovetail. So we select the tool. In the level, we need to define the ceiling and the floor, give the down step, and a few seconds, you get the answer. Very easy and very smart. Eye machining. Now, this is a prismatic part. We have to remove all the material inside, as we can see here. So we will select the eye machining, but we select the option of 3D prismatic because it's a prismatic part. And another thing, we have a multiple tool to use. We can select a few tools for the rough, for the rest material. So eye machining with the wizard, with all the technology, will generate automatically 3 operations automatically, as we can see now in this simulation. First comes the first tool. Open the part. This is the rough with eye machining. Open all the pocket. Now comes the second tool automatically. Make the rest and finish with that. Now, if we want to use another eye machining operation in another position. So we need just to, we have a recognition, we have a feature recognition mode. We can just click on the face, and automatically we will get the external and with all the geometry of the bosses. We will select in the same way the wizard. And when we look at the toolpath here, we see a very strange but amazing toolpath which combine a morphing spiral and radial, which is so unique to SolidCAM. And we jump to thread milling. We need to make thread on all this hole. So we have a specific operation, thread milling, very easy to use, like drilling. We select in the toolkit, we need to define number of flutes. And it's so easy because we have now all the standard of the thread, like metric, like inch, BSP, and so on. So the user needs just to select from this standard which thread he need to make, define the depth, if it's right thread, left-hand thread, so on, and automatically we get fantastic helical movement of the thread. This is the toolpath, and we can see now how the tool by Solid Verify is making all the thread all around. HSS is perfect solution for every surface. Today, as you can see here, the toolpath is amazing and very easy to use. We just define the surface, and without boundaries, even without boundaries, we just need to select the scallop and the tool, and we get a fantastic result, as we can see now. We select, in this case, it will be a ball nose tool. Scallop is the quality of the surface here, and we get very easy. And we have a lot of strategy inside. This is just one of them. And now we want to make the finishing operation of the part, so we have HD barring. It means chamfering. Now we have automatic recognition of this. The system automatically recognizes all the sharp edges in the part. You can select, there is a filter that can work for you, and then we select the chamfer depth, the tool, of course. Chamfer, in this case, will be a chamfer mill tool. Chamfer depth, in this case, 0.3. And we get fantastic results in few seconds. This is very strong, and customers like it very much. OK, now we will run everything, but in another simulation that SolidCAM provides today. A new simulator, it's called, OK? But what is the advantage of this simulator is that it can run standalone windows, a single window. So the advantage is that you can run the simulation, and in parallel, you can continue to work on the operation. So it's useful when the part is big, there is a lot of time of simulation, then you can, in parallel, you can do it, and it's a fantastic option. And it's also very, very nice simulation of SolidCAM with a lot of other benefits. And now we have also another tool. It's a Simco editor. So when we generate the G-code, automatically we can simulate the G-code, because the customer don't all the time understand. They think if we run the machine simulation, that it means it's 100% safe. It's not. So if they want to be, for sure, be sure that there is no problem in the part, there they need a G-code simulator. As now when you have the Simco editor, now we will have also Vericut. OK, so as you can see here, first, it's very, very nice simulation. And as you can see, it's run on the G-code file and simulate the G-code file. First, it's very fast simulation. And the programmer or the operator can jump to every part of the G-code, and directly you will see the result. You can see where we stay in the simulation, as we can see here. And the main goal of this simulation, of course, is to see a collision. So we can see, first we see now the part, and now if we want to see a collision between the holder or the tool with the part, so we will see it, we can see, and the simulation will automatically stop. You can see it now. Yeah, this is some collision in the middle of the part. And to the end, we have, as I said at the beginning, we have a solution to the operator. So the programmer finished with the part, finished with all the operation, but now he transfers it to the operator, and the operator needs to understand exactly what is the meaning of the programming here. So the operator have all the tools, like the setup, as we can see here. You can see the setup, you can see how the programmer defined the work coordinate system, which fixtures he defined. He going to the toolkit and can see all the tools with the holders, with all the necessary data information to him to prepare the setup. As we can see here, this is a T-slot. You can see the probe and all the other tools, important tools. Of course, you have all variety of simulation, include machine simulation that we can see here. And also, the operator have ability to modify the program. I don't know if you know, but in SolidCAM for operator, we have a swim mode. We have an editor mode. The editor mode let the operator to change things inside the operation or the toolkit and so on. And also, we have a light. A light is give him the option to change that in the toolkit, and you have a simulator, which he can change that. He just can simulate the part. In this case, for example, if the operator feels that in iMachining he can run more aggressively, so he can change the machining level, for example, to 6 here, can save and calculate, and get the results by himself. So it's a great tool, and I recommend everybody to convince the customer to have SolidCAM for operator also. Okay, next thing is Swiss type. Swiss type machine, our complete solution for Swiss type. So, you know, there is no many competitors that have solution to Swiss type today. We are one of them, and absolutely we are the best of them today. We provide all the necessary tools to the customer of Swiss type. We support so many brands, and the major brand is Citizen, Star, Tornus, DMG, Sprint, Tsugami, Nexter, and Anawa. We have a fantastic solution to Swiss type. We have a post database today, and we have a good team also, technical team, and all the resellers need to have also good technical people for Swiss type. So let's see another example in this case, for Swiss type. So this machine, this part is very, very small part. In Swiss type, you know, all the parts are very small. It's 20 millimeter and 5 millimeter. Accuracy is very important here. And in this case, it's a series of 3,000 pieces. So again, every second is so important here. We can see in this part, just a second. Going one, no. Thank you. Jack, bring me back, one more. Okay. No. Just a second, it's a video. Okay, just a second. No, that's it. Now it needs to run now. Yeah, okay. I think, yeah. Okay, so there is very, very small part. You see there is a hole that's less than 1 millimeter here. Height here is 2.5 millimeter. This is very complex part. And the goal is to finish with this part in one setup, and very accurate. So we have a fantastic machine preview in SolidCAM, that the programmer first in Swiss type, he can see all the tool, how they mounted in the station. This is very important. In Swiss type, this will be exactly the picture of the operator near the machine when he's going to prepare the setup. So we have exactly the same picture inside SolidCAM with machine preview. It's fantastic. You can see every tool in the station, and after it, we can continue. So let's see how we continue. We continue to the setup, and in the machining setup, we can see here that we have two kinds of setup. One, in the main spindle, how we prominent the material, and in the back spindle, we see a spatial fixture that will hold the part after it from the backside. And also Daniel talked about this, which is necessary in Swiss type. This is the channel synchronization screen. Very, very friendly, easy to use, and you can, in this case, you can optimize the program, which is so important in Swiss type. So we can decide which operation will work with each operation, and by this to optimize the program. And let's simulate it. So we start with machine simulation. We profile around the part with two sides of the part. We continue. The operation in Swiss type is very short. The tools are very close one to another, so we need to be very careful. The simulation is very, very important here. And as we can see now, two operations working together. You will see it later. Now, you see here. This is by the channel synchronization. We made it, and two operations working simultaneously. And now we're starting to cut the part from one side, rotate it to 180 degrees, continue to the other side, and now we can see also two HSS operations, for example, working together. This is save a lot of time, of course, to machine the part. This is real part of our customer. And now we're going to the cut-off, what is called cut-off in Swiss type. We will hold the part with the back, cut it. It can be with a grooving tool or with milling tool. Send it to the back spindle, and we finish all the operation from the back side. Okay. So our solution today is to all kind of CNC, as I told you at the beginning, to milling machine, all kind of milling machine, machining center, to all kind of mill-turn machine, multitasking machine, Swiss type machine, wire cut today also. We have solution to wire cut, and so it's a great solution. So everything unified workspace under the same SolidCAM umbrella. This is our solution. This is our complete solution, and I hope you enjoy. Thank you.